Everyone, we're doing a continuation of 10.3. This is 10.4 coordinate proof, and this time we're dealing with quadrilaterals, so not just triangles. We can extend it to our four-sided figures as well. And the same tips apply. So here we are in the coordinate plane. You want to, as much as possible, use the origin. So stick the origin either at the very center of a figure or at one of the points, or try and keep it here in quadrant 1 so the values stay positive. You may find yourself wanting to center it or to use the axes as much as possible. So just some general tips that will come up. Our first example here is prove or disprove that the quadrilateral determined by the points, these guys, is a parallelogram. And we've kind of done this already. And here we're just stretching a little bit. Instead of just proving it using slope, there are other methods to prove it, right? So the slope method is the one we've done before. We can look at the slope of AB. Oh, hey, look at that, that's 3. We look at the slope of BC, that's 2/5. Look at the slope of CD, that's 3. We look at the slope of DA, that's 2/5. And we go, oh, it's a parallelogram because opposite sides have the same slope. Cool, that works. Alternatively, if you're not as comfortable working with slope, you could use the distance formula. And I'm just going to blast through these, because hopefully by now you can use the distance formula. But right, it's the difference in x is squared plus the difference in y is squared, and then square root that sum. So if we find the distance between AB and we compare that to the distance between CD, it turns out it's the same. Similarly, BC and DA have the same distance. Opposite sides of a parallelogram have the same length, right? That's one of our conditions for a parallelogram, so therefore we can say it's a parallelogram. Hooray! Of note here, there are other ways as well that aren't discussed in the book. We can use any of our criteria for a parallelogram. For example, we could say that we have one pair of sides that is both parallel and congruent. That would work. What's difficult is to do the angles, because at this point you guys don't have the skills to calculate angles in the coordinate plane. So we're not going to do any of the angle stuff unless it's a rectangle. So keep in mind that this is another option as well. Okay, I'm going to skip number 4 here, but I want to do number 5. So write a coordinate proof given quadrilateral ABCD with vertices A, B, C, and D. So we want to prove, in this case, that the diagonals of A, B, C, D bisect each other. This one already did the slope thing. You guys are good with that and have done that before. But how are we going to show that these the diagonals of this parallelogram bisect each other? So go ahead and work on that. So pause here. Okay. Hopefully you figured out how to even figure out what the diagonals are. Again, just like most quadrilaterals, they're going to go in order around the quadrilateral. So it goes A, B, C, D. That means AB is a side, BC is a side, CD is a side, AD is a side. That means the remaining two relationships, AC and BD, are your diagonals. So we can calculate the midpoint of DB. We can say, oh, hey, look, that's at 4, 1. Ba-doop. Similarly, we can figure out that the midpoint of AC is at 4, 1. Ba-doop. So the diagonals bisect each other. Yay, that's one of our properties of parallelograms. Cool. So that one works. Let's see if we can do number 7 over here. Sure. Smooth. Okay. So in order to prove it's a rhombus, we need to prove that it's not only a parallelogram, right? So we've proven it's a parallelogram by using, oh, that's probably smoother. Okay, I was going to use slopes to prove it's parallelogram, but we can actually just skip that whole step. We can go to the properties of a rhombus, right? And one of the properties of a rhombus, the main one, is that all the sides, I'm drawing like a square, but that's a rhombus, all the sides are congruent. So in this case, we can use distance formula to figure out that this side is equal to this side, which is equal to this side, which is equal to this side. Of note here, they have chosen 3, 4, 5 triangles. So really you should be able to whip out that's 5, that's 5, that's 5, that's 5 really pretty quick. Because that will help you on future tests. Similarly, we could make a conclusion about the diagonals being perpendicular, because perpendicular lines have opposite reciprocals for slopes, right? Okay. This is kind of like doing a proof, but in this case, we're just determining which figure it is. We've done this before, but all we did was determine whether or not it was a parallelogram or a rectangle. Here we can get a little more detailed because we're just throwing in the distance formula, and we're using things like midpoints and stuff like that. So we should at least be able to figure out if it's a rhombus. And then if it's a rhombus and a rectangle, we can figure out if it's a square. So we can look at our points. The first step is to determine, well, we can do slopes or distance either way, but in this case we're looking at the slopes of the diagonals. So the slopes of the diagonals are different. So we go, the slopes, or if the, no, they did distance, they didn't do slope. They looked at the length of the diagonals and they said, oh, the length of the diagonals is not the same, therefore it's not a rectangle. And then we can check to see if it's a rhombus by looking at the slopes of the diagonals. And are the slopes of the diagonals opposite reciprocals? Yes, they are. Therefore, the slopes of that, those are perpendicular. Note here that it already told us it's a parallelogram. So we don't have to prove its parallelogramness. Okay, number 9, I'm actually going to work through number 9 here. So we can just do this one together. It says use the diagonals to determine whether a parallelogram, okay, so we have all the properties of parallelograms, we don't have to prove it, with a given vertice is a rectangle, a rhombus, or a square. So give all the names that apply. So again, we'll check the diagonals, we'll see if those are, see if it's a rectangle, because if both diagonals are congruent, then that means it's a rectangle. So what is Km? So I'm going to write Km. Here I'm trying to find not the slope, so I'm not going to put the slope sign, but I'm just going to put Km itself is equal to the square root. And here I'm gonna shortcut a little bit. I'm not going to write the values down. I'm just going to do the subtraction in my head. So I'll do the m minus the k value. So what is 3 minus 5 is, or 3 minus negative 5 is 8 squared, plus 1 minus negative 1 is 2 squared. So that's equal to the square root of 64 plus 4 equals the square root of, oops, I can math. Gives me 68. Okay, and then I want to find the length of Ln. So Ln.
You can write.
She's not helpful.
I'm a helper.
Okay, the length of Ln, same sort of deal. We can do the square root. Again, I'm going to do this one on the right, minus 1 on the left. So 0 minus negative 2 is 2 squared, plus what is negative 4 minus 4 is negative 8 squared. Remember, it's negative 8 squared, not negative 8 squared, which gives us the square root of 4 plus 64, which equals the square root of 68. Hooray! That means it's a rectangle. Right? So we're good on the rectangle properties. I'm just going to write this. Maybe I'll, because I'm going to erase this so we have more room. I'm just going to write yes over the rectangle part. So if it's a rectangle, next we're going to check if it's a rhombus. So how do we check if it's a rhombus? Well, we're going to look at the slopes of those diagonals, and we're going to see if they're perpendicular to each other. So the slope of Km, so I'm going to write m of Km is equal to, remember the difference in y's over the difference in x's. So 1 minus negative 1 is 2 over 3 minus negative 5 is 8. So that's 2 over 8, which equals 1/4. Cool, and then I'm going to get the slope of ln. So I'm going to take one of the y values here. So y minus y value, or negative 4 minus 4 is negative 8. I'm going to divide that by 0 minus 2, which is 2, which gives me negative 4. So the question is, are these opposite reciprocals? Yes, they are. So, is it a rhombus? Yes. What's the name of a shape that is both a rhombus and a rectangle? It is a square. Hooray! So we can just call it a square. Call it good. Whoops. I'm gonna erase my stuff. Okay. Similarly, we can do something similar for 10. If you do 10, it comes out so it's a rhombus. The diagonals are not equal, so it's not a rectangle. How can you use slopes to show that two lines are parallel? Again, parallel lines have the same slope. Perpendicular lines have opposite reciprocals for slope. When you use the distance formula, you find the square root of a value. When finding the square root of a value, you must consider both the positive and negative outcomes. So remember, this is just my reminder that in algebra class, when you're asked to calculate the square root of 9, you can have two possible answers. It could be 3, but it could also be negative 3. So in our case, since we're dealing with the coordinate plane and we're dealing with shapes and lengths and stuff like that, we can't have negative length. So we're not going to worry about these negative results. But this is my warning that you'll get to algebra 2 and you'll have to do square roots, and you'll have to remember that it could be a negative value when you go to do that, right? Like x squared equals 9. So this could be a negative 3 or a positive 3. So just keep that in the back of your mind. But that's it. That's all I got. Thanks.